All right, let's get right into it. There's a brand new, really critical cybersecurity flaw out there, and here's the kicker. It's not some theory. It's actively being used right now to hit systems all over the world.
And just how bad is it? Well, we already have confirmation that over 30 organizations have been breached. And honestly, that's probably just the tip of the iceberg. That's just what we know about so far.
And we're not just talking about tech companies here. The victims are spread across all kinds of different sectors, which just goes to show how wide a net these attackers are casting.
So, what's the potential damage? How many targets are out there? Researchers have found a pretty shocking number. Almost 78,000 IP addresses exposed to the internet are still vulnerable as we speak. Every single one of those is like an unlocked door waiting for someone to walk through.
This vulnerability has a name, React2Shell. And the most important thing to remember here is the urgency. This isn't a what-if scenario for some point in the future. The threat is real, and the attacks are happening on a huge scale right now.
So what in the world is this thing that's causing all of this chaos? Let's pull back the curtain and really decode what React2Shell is, how it works, and why its impact is just so massive.
Okay, so the official term is an unauthenticated remote code execution vulnerability. Now that sounds complicated, but the most important word there is unauthenticated. It means an attacker doesn't need a password, they don't need a username, they don't need to be logged in at all. All they have to do is send one cleverly designed web request to a server, and just like that, they can run their own code.
You know, the scary part is just how simple the attack is. It's really just 3 steps. 1, the attacker sends their malicious request. 2, the server gets confused trying to process some data in that request. It's a technical hiccup called unsafe deserialization. And that's it. That's the crack in the armor they need. Step 3, the attacker can now run pretty much any command they want on that server. It's incredibly direct and, well, incredibly effective.
So who's at risk here? Well, the flaw is in a feature called React Server Components. This means any framework using this tech is vulnerable, and that includes a really big one, Next.js. If you're not a developer, just know that Next.js is one of the most popular frameworks on the planet for building websites, and that's why the number of potential targets is just so enormous.
Okay, so we've got the what. Now let's talk about the who and the how. Who are the people, the groups, actually using this flaw, and what does their game plan look like? This is very much a global issue, but you can see from this chart that the United States has the biggest bullseye on its back, with nearly 24,000 vulnerable IPs. That makes it a top-tier target for anyone out there scanning for weaknesses. And oh, they are absolutely scanning. Security teams have spotted over 180 different IP addresses that are just constantly automatically probing the entire internet, like a fleet of robots hunting for servers that are weak to React2Shell. It's a non-stop, worldwide search. And here's where it gets really serious. According to researchers at Palo Alto Networks, some of the scanning isn't just random hackers. They're seeing activity that, with high confidence, they're linking to what's called an initial access broker, a group that's suspected of having ties to the Chinese Ministry of State Security. These brokers are basically specialists. They break into networks and then they sell that access to the highest bidder. And their method is pretty clever. It's usually a 2-step dance. First, they do something incredibly subtle, like telling the server to solve a simple math problem. It's like a quiet little knock on the door to see if anyone's home. If the server responds correctly, they know it's vulnerable. Then comes step 2. They hit it with more complex commands to download malware and set up shop inside the network. So once they're in, what do they use? We're seeing 2 main tools. The first is a piece of malware called Snowlight. Think of it as the delivery guy. Its only job is to sneak in and then download even more nasty software. The second is vShell, which is a backdoor. It's like leaving a window unlocked so the attacker can sneak back in and control the machine whenever they want.
Thanks to all this intelligence gathering, researchers have actually started to put names to the attackers. The groups identified so far include ones known as Earth Lamia, Jackpot Panda, and that group we mentioned earlier, UNC 5174, which has those suspected links to the Chinese state.
With sophisticated attackers moving this fast, you can bet the cybersecurity world had to kick into high gear. This started a global race to get this flaw patched. So let's look at that response and, most importantly, the solution.
This timeline just shows you how fast everything happened. I mean, look at this. The flaw is disclosed on December 3rd. The very next day, a working exploit is out in public for anyone to use. Almost immediately, big players like Cloudflare rushed out protections, and by December 26th, the US government had to step in and mandate patching for all federal agencies. It was that serious. A huge part of the defense came from companies being proactive. Cloudflare, for example, protects a massive slice of the internet. They quickly updated their web application firewall. You can just think of it as a digital shield for websites. They added new rules to that shield specifically to spot and block any React2Shell attacks before they could even get close to their customers.
The US government's move was also a really big deal. When CISA, that's the Cybersecurity and Infrastructure Security Agency, adds a flaw to this official catalog, it's not just a friendly suggestion. It becomes a binding order. It means federal agencies are now required by law to fix this vulnerability, and fast.
So what about the fix for everyone else? Well, the good news is it's pretty straightforward. It just takes action. Developers need to do 3 things: update their code to the latest patched version of React, rebuild their entire application using that fix, and then redeploy that new, secure version to their servers.
And all of this really brings us to a final, bigger question. The story of React2Shell is a perfect example of how one tiny flaw in one popular piece of software can be found and turned into a weapon used across the entire planet in just a few days. It really makes you wonder, as we build more and more of our lives on this complex digital foundation, is it all a lot more fragile than we'd like to think?